A radar controller's primary duty is to separate airplanes. But what exactly does that mean? And what methods can be used? My name is Kyle Warner. We'll take a look at what the 7110.65 has to say about separation, and we'll see what the different methods look like in our radar lab today on ATCast.
Thank you. JetBlue 1264 Boston, ground taxi ramp via November and Alpha. Boston Tower, Gulfstream 717, I'm for Bob Swifty on the ILS 4 right approach. Yes, there's 741 is checking out. 741 Boston Tower, good evening. Thanks for calling 737 distance time mil. I'm like pulling clear to land. Touch by 1005. 417, thanks for the service. Terminates clock VFR for the change. We'll send way back. Okay, 117, okay, good night now.
Dan Lindsay joins me from the radar lab today to talk more about separation. Dan?
Thanks, Kyle. We're going to be talking specifically about separation in the terminal radar environment. There are other methods that apply in the en route and non-radar environments, but in this episode, we're going to focus on what you'll need to know in your radar classes here at UND. We'll start by looking at the rules laid out in the 7110.65. Then we'll look at the methods for applying separation. Finally, we'll wrap things up with a review.
First of all, when do you have to provide separation between aircraft? For our purposes, separation must be applied between radar-identified aircraft that are operating under Instrument Flight Rules, or IFR. The rules governing the application of the different separation methods are found in the 7110.65 in Chapter 5, Section 5, Radar Separation. Paragraph 1b states, radar separation may be applied between radar-identified aircraft, an aircraft taking off, and another radar-identified aircraft when the aircraft taking off will be radar-identified within 1 mile of the runway end. So in order to apply radar separation, the aircraft must first be radar-identified. This can be either an aircraft with an IFR flight plan, in which case you'll see a full data tag with it, or one that has been assigned a discrete squawk code. It can even be a primary-only target. Paragraph 2a describes how separation minimums should be applied. Essentially, the minimum separation distance, 3 miles in the terminal radar environment, begins at the center of a primary target, as opposed to the edge of the target. For beacon control slashes, separation is measured from the ends instead of the center of the target. These are found on older radar systems and will not be used in your classes here. As you can see, separation is always measured from the ends of beacon control slashes and from the centers of primary targets. The displays in the radar lab are all digital. Digitized targets are treated just like primary targets, in that separation is measured from the center of the target and they should never touch. Now let's get into the separation minimums themselves. These are covered in paragraph 4. Separate aircraft by the following minima. When less than 40 miles from the antenna, 3 miles. When 40 miles or more from the antenna, 5 miles. These standards apply to aircraft at the same altitude. Aircraft can also be separated vertically, which we'll talk about later. Academy Approach's airspace extends to a 35 nautical mile radius around Academy Airport, and the radar antenna itself is located on the airport, so for the most part, your traffic will be less than 40 miles from the antenna. However, the 5-mile rule may apply to traffic in the Bartles Shelf, so keep that in mind if you have traffic heading to Bartles Airport. These same minimums apply when separating aircraft from obstructions, as shown in Chapter 5, Section 5, Paragraph 9. There are 2 obstructions in Academy Approach's airspace, shown here. The dashed circles around them show a 3-mile radius. Vertical separation can also be used to separate aircraft from obstructions. Keep in mind that the requirements for wake turbulence separation override these minimums, and can result in you needing more than 3 miles between aircraft. See Episode 2 of ATCast for more about wake turbulence separation. Paragraph 8 discusses another situation where separation minimums are increased. You'll probably see this most often with military aircraft. The formation is controlled as a single unit, and 1 mile is added to the separation minima. So if a formation of fighters is moving through Academy Approach's airspace, you would apply 4 miles of separation between the entire formation and any other IFR aircraft. If there were 2 formations, they would have to be separated from each other by at least 5 miles. The last rule to go over deals with adjacent airspace, meaning sectors under the jurisdiction of other controllers. For example, Approach North and South are adjacent, as are Aero Center and Springfield Approach. Paragraph 10 provides a set of minima that must be applied between aircraft under your control and the edges of your airspace boundary. When less than 40 miles from the antenna, 1.5 miles. When 40 miles or more from the antenna, 2.5 miles. These minima apply to these boundaries between approach north and south, Aero Center, and Springfield approach. Think of it like this. This rule ensures separation between aircraft in both sectors of Academy approach, because if the north controller maintains 1.5 miles between his or her aircraft and the airspace boundary, and the south controller does the same, there will be at least 3 miles between aircraft in both sectors at all times. Coming up next, we'll look at some methods for applying separation between aircraft. True or false? Separation is measured from the edge of a digitized target. The answer is B, false. Separation is measured from the center of a digitized target. What is the separation minima for aircraft that are less than 40 miles from a terminal radar antenna? Assume there's no wake turbulence involved. A, 3 miles, B, 4 miles, C, 5 miles, or D, 6 miles. The answer is A, 3 miles.
There are basically 3 types of separation you can use.
The radar separation minima of 3 miles, vertical separation, and passing or diverging separation. Applying the radar separation minima of 3 miles means keeping aircraft at the same altitude or within 1,000 feet of each other, at least 3 miles apart at all times. Factors you as the controller need to be aware of when using this method include aircraft performance characteristics, speed, and weight category. Remember that wake turbulence separation requirements override the 3-mile rule. Also, this is the only actual radar separation method. The term radar separation always refers to miles between aircraft as measured on a radar display. The other methods we'll discuss aren't actually radar separation methods, but they are just as valid for maintaining separation. Maintaining vertical separation means keeping aircraft at least 1,000 feet apart vertically. There are some additional rules for using vertical separation. See episode 15 of ATCast, Vertical Separation, for an in-depth explanation. The third type of separation is passing or diverging separation. We'll go into a little more detail about this one. Passing is defined by the 7110.65 as aircraft are on opposite or reciprocal courses, and you have observed that they have passed each other. Diverging is defined in this way. Aircraft are on the same or crossing courses, and one aircraft has crossed the projected course of the other, and the angular difference between their courses is at least 15 degrees. In both cases, the aircraft involved must have passed each other. Until that happens, they are converging, and this type of separation cannot be applied. And how do you know if aircraft headings are diverging by at least 15 degrees? Ask the pilots to say heading, or assign diverging headings to them. If their headings are not at least 15 degrees apart, and you have not already assigned diverging headings, you must do so in order to apply this rule. By the way, you see this method used in class all the time with departures from Academy Airport. In order to use simultaneous departures from the parallel runways, Academy Tower applies separation by issuing headings to departing aircraft that differ by at least 15 degrees. So if one aircraft departs runway 28 left at the same time as another departing from runway 28 right, they are separated because they are on diverging headings, even though a conflict alert may appear on your display. These aircraft are converging, and these are diverging. These aircraft are diverging because they have passed each other. These are converging. And now they are diverging. These aircraft are converging. And these are diverging. There's one more rule in the 7110 regarding passing or diverging. The tracks are monitored to ensure that the primary targets, beacon control slashes, or digital target systems will not touch. Therefore, at no time when applying these rules can the targets touch on your radar display. Controlling a sector successfully and efficiently will require you to use all 3 types of separation together, so memorizing these rules and practicing in the lab is key. Coming up next, we'll review the key concepts from this episode. Which of the following is an example of radar separation? A. Passing or diverging separation. B. 3 miles. C. 3 miles and 1,000 feet. Or D. All of the above. The correct answer is B. Radar separation refers strictly to mileage as observed on a radar display. Complete the following statement to make it true. When applying the passing or diverging separation rule, the aircraft in question must have blank each other. A. Intersected. B. Observed. C. Passed. Or D. Have communications with. The answer is C. The aircraft must have passed each other in order to apply the passing or diverging separation rule.
Now for a quick review.
Separation must be applied between aircraft that are radar identified and which are operating under instrument flight rules, and is measured from the centers of primary and digitized targets and from the ends of beacon control slashes. If less than 40 miles from the radar antenna, targets must be kept at least 3 miles apart at all times. If they are 40 miles or greater from the antenna, then they must be kept at least 5 miles apart. The same distances apply when separating aircraft from obstructions. Wake turbulent separation requirements may increase the separation minima depending on the types of aircraft involved. Aircraft must also be separated from airspace boundaries. If the boundary is less than 40 miles from the radar antenna, the minimum distance is 1.5 miles. And if the distance is 40 miles or greater, the minimum is 2.5 miles. There are 3 ways to apply separation in the terminal radar environment: the radar separation minima of 3 miles, vertical separation, and passing or diverging separation. Using the 3-mile rule means keeping all aircraft at the same altitude or within 1,000 feet of each other or obstructions at least 3 miles apart at all times. Using vertical separation means keeping aircraft separated from each other or obstructions by at least 1,000 feet vertically. To use passing separation, the aircraft must have completely passed each other. For diverging separation, the aircraft must have passed each other's flight paths and their courses must diverge by at least 15 degrees. In both cases, the targets must not touch on the radar display.
That's it from the Radar Lab. Kyle, back to you.
Thanks, Dan. On behalf of UND Air Traffic Control, the Student Air Traffic Controller Association, and the Aerospace Network, thanks for watching. My name is Kyle Warner. Frequency change approved.
Learn more about UND Air Traffic Control and watch more episodes of ATCast by logging on to www.undsatca.org. Students may interactively test their knowledge by taking the ATCast quizzes on SATCA's Easy LMS page. ATCast can also be downloaded for free to your portable media device. Just search for ATCast on iTunes U.